Okay, ladies and gentlemen, welcome to Math 20-1, Chapter 5.1, Solving Quadratic Inequalities in One Variable. Now, before we get to quadratic inequalities, let's look at linear inequalities, one unknown. So, x minus 4 is less than 0. So how do we solve that? Well, I'd add 4 to both sides, so x is less than 4. Now, if I want to put that on a number line, notice not a graph, a number line, we want to find 4. Now notice I haven't labeled the numbers on this. If I had, you'd just find 4. If not, choose one of them and call it 4. I suggest something in the middle. Now here, x is less than 4, which means everything to the left goes like that. Shade it like that. Some people go an arrow up pointing like that. Please don't do that. That gets very messy very quickly. Shade the line itself. Now, next one, x plus 3 is greater than or equal to 0. So subtract 3 from both sides. So you get x is greater than or equal to minus 3. Once again, put it on a number line. Let's go to the middle, since I haven't labeled them. Minus 3. Everything greater than, so that's to the right here. And I include the number 3 itself, so I make this a solid dot. Note the first one, the blue one, x is less than 4. We do not include the 4. Now the final, the final one, 4 minus 2x is less than 0. We want the x all by itself, so I suggest more than one way to solve it. Don't care. Minus 2x is less than minus 4. Now how do you get rid of times minus 2? Yes, divide both sides by minus 2. So you get x, 2. And what happens when you multiply or divide by a negative number? The inequality changes direction. So this becomes x is greater than 2. Remember that. So let's put 2 in the middle. And everything to the right. So far, so good? Good. Now, a quadratic inequality is nasty. Let's build up to that. I'm going to start with y equals 4 minus x squared. So you can graph this, or you can factor it and go, oh, that's a difference of squares. That's 2 squared minus x squared, or 2 minus x times 2 plus x. And remember, if we're solving it, we set it equal to 0. So 2 minus x is 0, minus, subtract 2 from both sides, minus x equals minus 2, or x equals 2. 2 plus x equals 0, subtract 2 from both sides, x equals minus 2. So I have my two x-intercepts here are my solutions. 0, 2, minus 2. Okay, so far so good? Now notice I'm doing a number line, not a graph. If you want to do the graph, and that's fine, you graph it and it goes like that. Okay? I'm just doing the number line because I find it conceptually easier here. Now, here's the tough one. Solve y is greater than 4 minus x squared. Now, this one is a little sneaky because it's not immediately obvious, but you want to say y is greater than. And remember how we had it set equal to 0 now? But the greater than sign means y is greater than 0 or positive. That's the sneaky thing you have to remember here. So we're looking for positive numbers. Now, we just solved y equals 4 minus x squared. And we got our values of minus 2 and 2. Now here, these are what we call critical values. So we have a critical value at minus 2 and at 2. All right? Now, the new thing here is we have to find where the function is positive. Now, to do that, we look at these critical values and we check a number in each section. Now, some people will call this section 1, section 2, and section 3. That might be nice. I don't know. But in the first section here, I need a number Check. Now, what is a nice number? You can choose anything less than minus 2. Minus 10, minus 100, minus 1,000, minus a million. I'm going to choose minus 3 because it's a small whole number. Actually, it's a small integer. So, checking in section 1, y is greater than 4 minus 3 squared. Y is greater than 4 minus 3 squared is minus 9. Y is greater than minus 5. This is negative. Okay. So all my answers here are negative. No, that doesn't work. We want positive. So let's check section 2. Let me color code this. Section 2. Now, what's a nice number smaller than minus 2 and greater than 2? Or sorry, greater than minus 2 and less than minus 2 inside the section. 0, honestly, is the nicest one. Why? Because it's 0. Y is greater than 4 minus 0 squared. Y is greater than 4, which makes it positive. So every answer in this section is positive. So if I said x is minus 1, I would get a positive number. Y would be positive. I chose x as 1. I chose x as 1.99. I still get a positive number. Now, finally, I have to check the third section. Now, there's symmetry here, so it's probably all negative, but I'm going to check anyway. I'm going to choose a nice number like 3. So y is greater than 4 minus 3 squared. Y is greater than 4 minus 9. Y is greater than minus 5. So everything in this section is negative. And remember, I'm looking for positive numbers here. So where's a positive? In section 2 here. So my solution here is, oh, you Shazbot, stop that. Right here, the positive number 2, negative 2 is less than x is less than 2. Every x value bigger than minus 2 and less than plus 2. All right? Now, that is the long, proper way to solve this. Okay? Do you want me to show you the cheating shortcut? I'm assuming that's a yes. All right. Oh, no, you Shazbot, no. So the quadratic is y is greater than 4 minus x squared. Graph it, what you get. You get a parabola like this. Double check. Set your windows minus 10 to 10, minus 10, 10, 1. There we go. Yes, I graphed it right. Now, where is y value positive? Well, the y value is greater than 0 or positive above the x-axis. That is minus 2 is less than x is less than 2. Where is this graph negative? Y is less than 0 or negative below the x-axis. Here, y is less than minus 2 and y is greater than 2. It's negative. Since we're looking for positive, that's a solution. All right? Now, one little thing. If you go on looking at other videos, the people get lazy and don't write it out this way. They might write it minus 2 to 2, round brackets like that, but that looks like a coordinate. Don't do it that way. I'll try not to do it that way. in this class, but sometimes we do that in Math 30. Okay? Now, so if you can draw the graph and look at where it's positive or negative, it works. So let's look at this next one. X squared plus 2x is less than 8. Is that a quadratic? No. Can we turn it into quadratic? Yes. X squared plus 2x minus 8 is less than 0. That is, where is this negative? It's less than 0, so where's this graph negative or below the x-axis? Well, I'm going to be quiet. I want you guys to factor and solve it and find me the critical points. Okay, so this is x plus 4 times x minus 2 is less than 0. So x plus 4 is less than 0, or x is less than minus 4. Actually, I don't want to use the greater than. Let's make it equal to 0, sorry, to find our critical points. X is minus 4. X minus 2 is 0. Add 2 to both sides. It equals 2. Subtract 4, subtract 4. So I have minus 4. 3, 2, 1, 0, 1, 2. So I got my two critical points. Now, I know this is plus x squared, so this graph opens up. From chapter 4, y is positive here, and y is negative here. So, from drawing this graph, when is this negative? From minus 4 is less than x is less than 2. Now, that's from the graph. I need you to prove this algebraically, because I will ask you to prove it algebraically. So we have section 1, section 2, and section 3 over here. So choose a point from each section and check. Now, section 1. Now, I'm going back to the original equation just in case I screwed something up. X squared plus 2x is less than 8. All right, so I got that correct. X squared plus 2x is less than 8. Now, what is a nice number? Sorry, I keep flipping backwards and forwards. I'm going to get you sick. What's a nice number in section 1? Well, the smallest number, or nicest number I can think of is minus 5. I could use minus 6, minus 7, minus 100. Minus 5 squared plus 2 times minus 5 is less than 8. 25 minus 10 is less than 8. 25 minus 10, 15 is less than 8. Is 15 less than 8? No. So this section doesn't work. Now, section 2, x squared plus 2x is less than 8. What's a nice number to choose in the second section? Well, 0. Because what's 0 squared? 0. What's 2 times 0? 0. So 0, is 8 greater than 0? Yes. So this section works. So that's my answer. Now, well, I'm not going to say obviously, but I'm pretty certain the third section doesn't work, so choose a number there, like 3. Third section, x squared plus 2x is less than 8. 3 squared plus 2 times 3 is less than 8. 9 plus 6 is less than 8. Is 15 less than 8? No. So, I did that kind of quickly, but you guys are showing me you're sharp, and we're doing the graphing stuff here. Okay? Now, review this, and I'll slowly do the next one with you. X squared is greater than or equal to 7x minus 10. So here we have to turn this into a quadratic. Let's do that first. So I suggest subtracting 7x from both sides and adding 10. So x squared minus 7x plus 10 is greater than or equal to 0. That is, where's this positive? Now the second thing is we have to factor this. So, and factoring's a pain in the bum, minus 7x plus 10. Solve it, set it equal to 0. Now, some of you guys are going to graph it. Some of you guys are going to factor it. I'm going to factor it and find the critical points because x minus 5 times x minus 2 is equal to 0. Now I did that in my head. What I did, x squared minus 7x 10 x, two numbers that multiply together to be plus 10 but add to be minus 7, got to be minus 5 and minus 2. So x minus 5 is 0, x minus 2 is 0. Now we find our critical points. Well, instead, add 5 to both sides, x equals 5, and add 2 to both sides here, x equals 2. So if I go to my table of values, sorry, if I go to my number line here, 5, 2. Now, x squared minus 7x plus 10, that is plus x squared, which means it opens up. So, y is positive here, and y is negative here. We're looking for the positive parts. So here, my solution should be x is less than 2, oh sorry, less than or equal to 2, and x is greater than or equal to 5. But section 1, section 2, section 3, let's check because maybe things happen. All right, what's a nice number in section 1? I'd suggest 0 because it's a nice number. So checking, and remember, we check with the original equation just in case I screwed it up. So x squared is greater than or equal to 7x minus 10. Minus 10, yes. So this is section 1. So 0 squared is greater than or equal to 7 times 0 minus 10, or 0. Is 0 greater than minus 10? Yes. All right, section 2. X squared is greater than or equal to 7x minus 10. What's a nice number in section 2? I was going to say 3. It's a small number. I can do most of that in my head. 3 squared is greater than or equal to 7 times 3. 9 is bigger than or equal to 21 minus 10. Is 9 bigger than 11? No. Doesn't work. So section 1 works. X is less than or equal to 2. Now I'm willing to bet x is greater than or equal to 5 also works. Now notice I'm not choosing 5 itself because it's on the line. But I have to go to the third section. What's a nice number to choose? I'm going to choose 6 because I can. So, section 3 squared is greater than or equal to 7x minus 10. 6 squared is greater than or equal to 7 times 6 minus 10. 36 is greater than or equal to 42 minus 10. 36 is greater than 42, 32. Yes. So I do have it right. Okay. So x is less than 2, x is greater than 5. See how that goes? Oh. 2 more examples. All right. So x squared plus x plus 1 is less than 0. Now here's the problem. Can you factor that? No. So you either use the quadratic equation or you graph it. Now honestly, life is too short for the quadratic equation, and we just did chapter 4 graphing, so graph the darn thing. And what do you get? X squared plus x plus 1 is 0. It's up like that. Now, where does this cross the x-axis? It doesn't. There are no x-intercepts. So, no critical values. So let's double check that. Y equals here. x squared plus x plus 1 graph. It comes close, but it does not cross the x-axis. You guys see that? That's important. So there's no x-intercepts, no critical values, which means there's only one section to check, the entire thing. Either everything works or everything doesn't work. Now, this is negative, so choose a number on the number line. What is the nicest, easiest number to choose? 0. So plug in 0. 0 squared plus 0 plus 1 is less than 0. Is 1 less than 0? No. No x-intercepts, no solution. There's no number here we can choose that works. So I will give you a question like that. Right? Now, sorry, my bad. Okay, so be careful of that. Now, the other version of the question I could ask, greater than 0. That is, where does it work? Well, 0 squared plus 0 plus 1 is greater than 0. 1 is greater than 0, so they all work. So check and be careful how the equation's worded. So if I rewrite it, x squared plus x plus 1 is greater than 0, everything works. Okay? Now, last question, I'll leave you guys alone. You have 46 meters of fencing to make an enclosure. Can you make an enclosure that's at least 120 meters squared? All right? Now, go back to chapter 4, section 7. You're making a pen that's x by y. Okay? So sorry, 2x, 2y. Now, I admit this question's evil, but 2x plus 2y equals 46. 2y equals 46 minus 2x, or y equals 23 minus x. Why are we doing that? Because I'm evil, and because area equals x times y is that at least s greater than or equal to 120, or x times 23 minus x greater than or equal to 120. Now, I'm going to pause the recording. I want you guys to try working on, actually no, I'll help you with this because it's a little nasty. This is 23x minus x squared, or minus x squared plus 23x minus 120 greater than or equal to 0. Now, can we graph this? Yes, we can. So grab your graphing calculator and graph it for me. All right, so when I graph this, can you make an enclosure? So when I graph it, y equals minus x squared plus 23x minus 120. Now just double checking I got that. Minus x squared plus 23x minus 120. I get a graph like this. Now I got to play with my windows a little bit. 0 to 20, groups of 1. I may say 10. Yes, I can. Oh, sorry. And once again, the biggest problem here is finding my... Yes, I can. Here I have a graph. It's positive. If I look at my table of values... Okay, how'd that happen? No. So I go back. Yes, 15 and 8. Woohoo! So I go 8 to 15. So can I make a fence? Sorry, can I make an enclosure that's at least 120 meters squared? Yes, as long as the x length is greater than or equal to 8 and less than or equal to 15. Now, you guys take that number line, check a number less than 8, between 8 and 15 and greater than 15, and you'll see I'm right. All right, anyway, that's it for me. Good luck. And try the homework. Shoot me an email if you got questions.